Today I have an electric convection oven which I'm going to strip it down and modify it and turn it into a multi-fuel heater, which I can use different kinds of fuel for heating: cooking oil or waste oil, alcohol, candles, or even hand sanitizer. Basically any kinds of fuel that I can get my hands on for free, even wood chips or wood pellets. So here's the empty oven, which I have stripped it down to just a bare metal case. There's nothing left in there. All of the electronics, switches, the fan, and the heating elements, everything is out already. So here's the plan. I've got an exhaust from a motorcycle. It's actually just a metal pipe, and it's got a diameter of about 2 inches, and it is a little bit longer than the width of the oven, so it will stick out a little bit on this side and sticks out a little bit on this side. I'm going to drill a hole on the right side and a hole on the left side, and then I will thread the pipe through the 2 holes, and then I'm going to install a fan that blows air onto the pipe from one side to the other, and that's where I got my hot air on this side. I also need to make a hole on the back here for the exhaust air to come out. That's the smoke that comes out, so that the hot air that comes out this pipe here is completely clean and is not polluted by the burnt air inside the oven. And that's basically the plan, so let's get started. This oven has to be sealed, and my first problem is that it's got holes. So we got 2 holes, 2 big holes on top here from the heating element. There's a giant hole here from the fan, and on the other side we also got holes from the heating element, 4 holes. So I'm gonna have to find a way to cover up all these holes. I drill a hole on the left side with my 2-inch hole drill bit here. So this pipe will go in there just fine, and this is a very tight fit. I got about 1 millimeter of gap here, and I use JB Weld to seal the gap. And over here on the right side, I'm going to drill the same hole right here, but because there are so many gaps here and so many small holes, I need to cover up all of these holes. I cut a thin piece of aluminum sheet, and it's gonna fit in here to cover up all the holes. I got my hole drilled on this side. I kind of messed it up a little bit over here, but that's not a problem because I have another layer of aluminum which I cut a perfectly round hole, which is gonna stay on top like that, and my pipe is gonna go through this hole here. So here it is. I've been trying and modifying a lot of things on this for the last 2 months, and this is my final product. It's been harder than I thought it was. Let me show you what I've got here. So on the door I use carbon felt and glue it with JB Weld glue to seal the door, so when I close the door it will be sealed. And on the right side I install a 200 millimeter computer fan, and it runs on 12 volts, and this fan is going to blow air from this side through the pipe and out to the other side. And this is where I got my hot air from. So the fan blows cool air from the outside through the pipe, and it got heated up out to the other side. Let me show you my exhaust system. At the beginning I drill a small hole about 1.5 inches, and I use this is just a aluminum sheet, and I roll it to make a stovepipe, and I use JB Weld to glue it together onto the top here. But because the hole is too small, it's not efficient to bring the exhaust and the heat out of the stove, so it got too hot inside the stove, and it kind of melt the glue and makes this loose. So I went ahead and made a much bigger hole. This hole is 4 inches in diameter, and this is a pipe from a dryer. This is the elbow adapter, and it's adjustable. So first I drill a hole on the top of the stove about 3.5 inches in diameter, And then I use this elbow adapter here, and I cut out, that's about 1/2 inch every 2 inches. So every 2 inches there's a cutout, so that when I bend it 90 degrees, and I'm gonna be able to drill a hole straight down to secure this adapter onto the top of the stove. And you can see the screws goes all the way around. And this is the aluminum dryer vent. It's very flexible and it can take a lot of heat. The reason why I want to use a flexible aluminum hose is because I wanted to mount this onto a window if I'm in a house, or I can just mount it onto a window of a car if I'm in a vehicle. I want to make this stove heater as portable as possible. And then at the end of the dryer vent, I have a plastic adapter here, and this is where you mount onto the outside of the wall of your house, and this is where the hot air from the dryer comes out of the house. I install a 12-volt computer fan right on the adapter here, and amazingly it fits right on here, just snug fit. And then I have a large piece of foam, and I cut out a square so that this fan will fit right in this square hole here, and all of the exhaust gas is gonna come out of the house through this hole. The top of the stove pipe here is gonna get really hot, so I cut out a piece of aluminum sheet here, and I cut out little fins here, and it will act as a heat sink. I'm gonna put it on the stove pipe here, just like that. I'm gonna mount it on the stove pipe, and it will act as a heat sink so that I can pull as much hot air out of the stove pipe before all the hot air exits out of the house, and that will make the stove a little bit more efficient. This is the self-tapping screw I'm going to use to mount this piece of aluminum on here, and this is the size of the screw, and here it is after I install the aluminum heatsink. Isn't that beautiful? So next, let's talk about the container for the fuel, because the main heating pipe inside this stove here is long and narrow. I have to make my fuel container the same shape, which is long and narrow, and this is basically just the aluminum sheet that I fold on 2 sides, and then I fold again on the other 2 sides, and it becomes like a boat, like a canoe more likely, and it will hold any liquid in here. And this is what I'm going to use for liquid fuel. Talking about fuel, the fuel I'm going to use is vegetable oil, and in this case canola oil. And this is a free fuel, easy to get, and you can get a lot of these from a restaurant or even from your own house if you fry a lot of stuff. The thing is, this oil needs a lot of heat to burn efficiently. If I just pour this oil onto my container here and just burn it that way, it's gonna create a lot of soot, and it's not gonna be very efficient. And so what I'm gonna do is to use sawdust and mix with the oil, and the sawdust is gonna act like a wick and will help burn the oil a lot more efficient. And I have burned it a few times, and you can see in there's barely any soot in there. It's very clean burning fuel. Alright, so I've just put the sawdust in there. Now we're gonna pour the oil in here, and you want to put the oil in here just enough to wet the sawdust. You don't want to put too much oil in here, otherwise it won't burn as efficient. So here we go. You can see it's just enough to wet the oil, but it's not flooded. And because this oil requires a lot of heat to burn, if I just burn it right now, it won't burn very efficiently because it's not hot enough. So I'm gonna use some alcohol, and I'm just gonna pour it in here. Okay, I'm gonna mix it in here, and the alcohol is gonna act like a heat starter, and it will make the stove hot and will make everything in here hot enough so that when the alcohol is burned away, what is left is a very hot mixture of oil and sawdust, and it will burn very efficiently. Alright, let's put this to the test, shall we? I've got everything hooked up to my window here, nice and tight, and it is airtight. I've got my fuel in there right beneath the pipe, ready to go. So right now my exhaust fan is unplugged, and if I put my hand in here right behind the hole of the exhaust, I can feel rushing cold air from the outside going through this pipe here and goes into the stove. If I light up the stove right now, all the smoke is not gonna come out this way. It's gonna come out through every single gap I have on the stove, and it's gonna come out into the room. So I have to plug in my exhaust fan right now to pull all of the air outside of the room. Here we go. So right now you can see the flame is almost clear, and that's because right now the alcohol is burning, not the oil. Well, after a few minutes, when alcohol is gone, the flame is out also, and that's because it's too wet. I put too much oil in here, so right now I have to add more sawdust in here to dry it out. It has to be dry enough to burn. Take 2. And it's burning beautiful now. So right now it's 66.5 degrees Fahrenheit in my room, and the time is 7:52 p.m. The time is now 7:59 p.m. and it's been 7 minutes, and there is a significant change in the flame. As you can see, when it first started with the alcohol, the flame is bluish, and right now the flame turns into an orange flame, and that means we are burning sawdust and oil right now. That's beautiful, and this flame burns so clean. There's no soot on the top of the pipe, as you can see there. Nice and clean flame. There is a significant amount of heat coming out of this pipe. It blows air from this side, cool air gets into here, you got to heat it up, and what comes out of here is pretty hot air. Let's check out temperature out of this pipe. We got about 201 degrees Fahrenheit out of this pipe. There is also a lot of heat coming out of this heatsink. Let's check this out. About 143 degrees Fahrenheit out of this heatsink, so it's doing a very good job pulling heat out of the pipe. And the flame is very stable now. It's now 9:10 p.m. so we're about 1 hour and 20 minutes in. Temperature 76.8 degrees Fahrenheit right now, so it is about 11 degrees warmer in this room. I feel nice and toasty in here. The flame is still nice. It goes down a little bit. I think we're almost out of fuel. I think we have about 20% of fuel in there, but it's still going strong. So there you have it. This is how I turn an ordinary electric stove into a portable personal heater I can use to heat my room, my car, my RV, even a tent. It cost me next to nothing to make because this stove I got for free and it didn't work anymore. And all the parts I use here are the stuff I have lying around the house. And even the fuel I use to heat my room is also free. Waste vegetable oil, sawdust. The amount of oil that I use in there has a volume equivalent to 2 Tesla 2170 lithium-ion batteries, and it's enough to heat my room over 10 degrees warmer. So that shows how much energy is stored in this oil compared to lithium-ion batteries. This project actually took me a very long time to make after so many failed attempts. And that's all for now, folks. Thanks for watching, and I will see you next time.